All right, so we are going to talk about graphing reciprocal functions. Now, I told y'all the other day that I'm going to tell you what I know that you know and don't know about rationals, but I had only talked to the pre-AP Algebra 2 teacher, and I know not all of you came from pre-AP Algebra 2. Maybe everybody in here did, I don't know, but maybe not everybody watching the video. And so I talked to a regular Algebra 2 teacher as well, and apparently in regular Algebra 2, you actually finished rationals before spring break, so you had, the full lesson, basically, where the pre-AP kids got just the beginning, but it's okay. We're going to go through it this kind of the same for everybody anyway. So with that said, y'all should have seen the reciprocal function. This usually I do at the beginning with the rest of the parent functions, but we chose to wait until we got to rationals this year because parent functions has a whole bunch in it anyway. So what a reciprocal parent function looks like is this. F of x equals 1 over x. It's the reciprocal of the linear. Now, the type of graph, it is a hyperbola, but you probably don't know what that means yet, and we'll talk about those eventually, but it also fits in the rational category, and that's what I'm more concerned with right now. And what makes it a rational function is not just the fact that it's a fraction, but the fact that you have a variable in the denominator. It's fine that there's none in the numerator, but we have one in the denominator, and that's what makes it irrational. Okay? So let's take what we know about graphing and whatnot and substituting in numbers and plot some of these points. So let's say that we substitute 1 in for x. If I substitute 1 in for x, what do I get for y? 1. It's the hardest question of the day. Okay. If I substitute 2 in for x, I'm going to get 1/2, right? And then let's think about this. Then I'm going to if I substitute in 3, I'm not going to plot all these, but if I substitute in 3, I get 1/3, 4, I get 1/4, 5, I get 1/5, and so forth and so on. So I'm going to get closer and closer and closer to 0. Is there a number that I could substitute in for x that would give me 0 back out? No. Even if I did 1 over 1 million, that's a super tiny number, but it's not 0. And the larger the denominator gets, the smaller the fraction gets, so the closer and closer and closer I get to 0, but I never actually get there. So since I never actually get there, what is on my graph at 0? What would have to be there? What kind of stops me from going? The little dotted lines we've been drawing, what are they called? An asymptote, there you go. So I'm going to have an asymptote here because I'm never actually going to reach 0. I'm going to get as close, really close, but I'm never actually going to get there. Okay? So I know that much so far, just based on basic knowledge that we have. So I know it's going this way, so let's see what happens going this way. So I substituted in 1. Let's say I substituted in 1/2. If I substitute in 1/2, what do I get for y? Because I'd have 1 over 1/2. 2, because I'd multiply by the reciprocal, I get 2. So if I'm at 1/2, I get 2. If I go to 1/3, I'm at 3. 1/4, I'm at 4. 1/5, I'm at 5, and so forth and so on. What happens when I substitute in 0 for x? What do I get? What's 1 over 0? Undefined. It's not 0. It is undefined. So if it's undefined, what's on my graph? An asymptote, yes. So I'm going to have a vertical asymptote at 0 as well. So without graphing 1,000,000 points, those 3 get me my curve, and I know I'm going to come really close there, and then start getting really close here. That's what that part looks like. Okay, so now this horizontal asymptote, it is a line. It's a horizontal line. So is that line y equals 0 or x equals 0? Y equals 0. It is the x-axis, but it is y equals 0. Because no matter what point I pick on there, the y value is 0, but the x value changes. And my vertical ones are x equals 0. Now, hopefully you don't get those mixed up anymore. Okay, maybe you did originally, and I can understand by the axis names that maybe you did, but we can't do that anymore. So Here's a way if you do still ever, or you start to second guess yourself, because we all know, sometimes we totally know, but then you start to talk yourself out of it and you reason through things and then you don't know anything about anything anymore and you have trust issues with yourself. Like, I get it. It's called overthinking. So this is something Miss Ludicky showed me years ago from when she was teaching Algebra 1, which I love. So if you do get it mixed up, think about this. If you take a y, I'm going to write a y like you would in like an elementary school cursive, you know, like that kind of, that's what my little y looks like, right? Now, I know you don't have paper, and if you actually turn your tablet, it probably flips itself back around too, so it kind of loses some of its flair here. But if maybe you just think about, if I rotated that around upside down, then I'm going to get this, right? That's basically what it's going to look like if it's upside down. So y is a horizontal line. The y and the h go together. So that's a way to tie it to your head if you can't tie it any other way. Now, x is very unsatisfying because if you rotate that around, you still get an x, right? But if you split it in half, you get a v, so x is vertical, y is horizontal. So it's just like another trick if you need it. Hopefully not everybody needs it at this point, but maybe if you start overthinking things, you can reason through it yourself. Okay, so with all that said, let's finish up this graph because we only plotted 3 points. What happens on this side of the y-axis? Well, if I substitute in -1, I get -1, right? Substitute in -2, -1/2. -1/2 gives me -2. So I have this same sort of thing going on down here, like this. Okay. Everybody good so far? So that is your reciprocal parent function. And those 6 points are basically your anchor points that you can just kind of think through. So my domain here, I'm going from -infinity to 0. And then I start back over at 0 and go to infinity. Then the range is the same, -infinity to 0, 0 to infinity. My vertical asymptote, we've already decided, is x equals 0. Horizontal is y equals 0. What questions do we have? So since we know this much and we can sketch this, then we should be able to do our transformations as well. So along with the reciprocal parent function comes a reciprocal squared parent function. So let's look at that one. That one is just like it sounds. It's the reciprocal function, but it's squared. So let's think about our asymptotes first, because really that's what we always want to graph first. So now since we kind of know what's going on, our vertical asymptotes come from the zeros of the denominator. And if I was to set the denominator equal to 0, my answer is 0. So my vertical asymptote, I know I have a vertical asymptote at x equals 0. So then on this one, is there a value of x that I could substitute in that would give me 0 for y? No. If there wasn't on the first one, there isn't on this one. So I'm going to have a horizontal asymptote right here. Okay. So I could go ahead and say, okay, my vertical is at x equals 0. My horizontal is at y equals 0, just like it was on the other one. So let's go through some points. If I substitute in 1, 1 over 1 squared is 1. If I substitute in 2, that's going to give me 1/4, right? If I substitute in 1/2, what's 1/2 squared? 1/2 times 1/2 is 1/4. So I'd have 1 over 1/4, which gives me 4. Right? So at 1/2, I'll be at 1, 2, 3, 4. So those 3 points are good enough to give me my curve and get me where I need to be here. Look at this. Okay. So then I need to see what happens on the left side of the y-axis. If I substitute in a -1, when I square it, that's going to end me up at +1. When I substitute in a, what did I do, 2 and then 1/2? What did I say? Did I say 1/4? and I graphed 1/2 sort of. We'll pretend like that's at 1/4. Okay, as long as I said 1/4, we're good. Then if I go to -2 and I square that, I get 1/4. I think I just made my circle really big or something. -1/2 and I square it, I'll be at +4. So because this is reciprocal squared, I do not have any negative y values because I've squared them and they all become positive. And notice the symmetry here. If I had graphed this point better, I just don't want to start over. If I can get one side drawn, then it just reflects across that axis, and then I can get those other points. I can do that without counting them. So the type of graph, this is still a rational function. The domain, -∞ to 0, and then 0 to infinity, just like the other one. But my range is different. I'm just going from 0 to infinity. What questions do we have? Okay. So, like I said, we're going to take these and we're going to do the transformations that we already know how to do. Okay, so this is really what we're about to put on here is really no different than what we've been doing. It just looks a tiny bit different because we are, because of the way the parent functions are. So if I have f of x, okay, I'm going to have a in the numerator. Denominator is b times x minus c, and then plus d out here. And a, b, c, and d do the same thing as a, b, c, and d did before. And then for my squared function, I'd get a over b times x minus c squared plus d. So just like before, this c here is going to be my horizontal shift plus shifts left minus shifts right. Okay. When I add or subtract something at the end, that is my vertical shift plus shifts up minus shifts down. Now here a is in the numerator, which we didn't have a numerator in any other parent functions, but a always came first. And that represents, is that a vertical or horizontal something? When it's way out front. Because it happens, notice it happens after I take care of x. So that means that it affects my y. So this is the vertical stretch or compression. Right. So b, it's down there with x. And so it is the horizontal stretch or compression. And then anytime you have a negative, what does the negative do? It reflects, exactly. So I know where it says A is negative, B is negative, so we can say that it reflects, and then we'll figure out where it goes. And it's in some sort of axis, right? So B is in here before we actually square it, which means it affects x, and if I affect x, I actually reflect in the y-axis, right? So if B is negative, the second one, it reflects across the y-axis. If A is negative, it's the x-axis. Okay, we all good so far? So then the other thing we have here that we did not have in the other parent functions are asymptotes. My vertical asymptote, comes from the zeros of the denominator, so it will just be x equals c, and horizontal will just be y equals d. Any questions about any of that so far? Because the transformations, they work the exact same way. It just looks a little bit different because we have rational functions here. We good? Awesome. All right, so now let's look at writing functions with all of this stuff that we know. So number 1 says the reciprocal parent function is reflected, means I'm going to have a negative, across the x-axis, then translated 4 units right and 3 units down. So I don't have to worry about a or b. I just have c and d. So f of x equals, so it's across the x-axis, so I know that the negative has to be in the numerator. I'm going to translate 4 units right, which means this will be x minus 4 down here. And then 3 units down, I'll have a minus 3 out there. The last part of this says identify the asymptotes. So I have to identify the vertical asymptote and the horizontal asymptote. Vertical comes from the zeros of the denominator. So this would be x equals 4. Horizontal is your d, so it's y equals negative 3. Any questions at all? Then I want you to write the equation for number 2. Any questions? Do we agree? Did I give you enough time? Are we good? Awesome. All right, so let's graph a couple. We're not going to do all of these. Let's look at number 4. Okay, so I know I have a reciprocal function, so 1 over x type of situation here. The only thing that is happening here is a vertical shift down 2. You agree with that? So the first thing you always want to graph when you're graphing your any rational function are the asymptotes. So here's what affects the asymptotes. The vertical asymptote gets affected by a shift left or right. Is there any shift left or right? Nope. So then my vertical asymptote is still x equals 0. The horizontal asymptote gets affected by a shift up or down. Well, this gets shifted down 2, so my horizontal asymptote is now at y equals negative 2. So I'm going to go and I'm going to sketch those in. So I've got x equals 0 and y equals a negative 2. Okay. We'll worry about domain and range after we graph it, even though we could do it beforehand. It's a little easier just to graph it and figure it out. Okay, so here's the nice thing about these. So the rule has always been you do your shifts at last, like left, right, up, or down. That is the very last thing we do. But since this affects our asymptotes are where they need to be. So basically, I've already taken care of this minus 2 part. All I need to worry about is this now. Well, that is my parent function. So if I ignore my actual axes and use my asymptotes as my new axes, and then just graph my function. So basically, this is like my new 0, 0. So from there, for the parent function, I'd be at 1, 1, right? I'd have been at 2, 1/2, and I'd have been at 1/2, 2. And then it's shifted and everything for you. Say that again? Maybe. I can try. It's not as... me see. Too big. There we go. Is that better? Okay. Sorry. I know they're kind of small. I didn't realize I couldn't see them. So I just use this. These are my axes, right? So I'm at 1, 1, 2, 1/2, and 1/2, 2. And so then the same thing down here. 0, 0. So I'm at -1, -1, -1/2. I'm sorry, -2, -1/2. And then -1/2, -2. And then I can sketch this in. Ooh, but I don't want to go over my asymptote, so let me try that again. And here's a little hint on being careful when you sketch these, draw these in. On your paper, but really more importantly, like on Delta Math, because your assignment today is not on Delta Math, but you will have to do some of these on there. And this caused some of you some issues when you were sketching some of the other graphs. So my function is supposed to be, I'm really close to the asymptote, and then I'm getting close again. Here's what you have to be careful not to do. You have to be careful not to do something like this, because, okay, I know what you're trying to do, and I get it. This isn't an art class, but Delta Math is not going to like that for a couple of reasons. The whole idea is that you're supposed to be getting closer to the asymptote, and you're not. The other thing is this fails the vertical line test, and what you have isn't a function. Okay, so for that reason, that's why it seems like picky about that when it's not picky about other things. So just be careful with that when you're going towards the asymptotes. All right, so let's then talk about our domain and range. So our domain, we're going from -infinity to 0, and then 0 to infinity. Range, -infinity to -2, right, because I moved. And then -2 to infinity. Everybody good with all that? Awesome. Okay. So then we are going to do number 6. Let's look at number 6 here. All right, so number 6 is my reciprocal squared function. And so let's talk about asymptotes. Our vertical asymptotes come from the zeros from the denominator. The zeros of the denominator is going to be 0, so I still have this at x equals 0. The horizontal asymptote gets affected by the shifts, so I went up 1. That means this has to be y equals 1. So I will graph those. I have x equals 0. And I have y equals 1. So again, I'm going to use those as my new axes and pretend like the other ones aren't there. So this part right there is already taken care of. So I have to worry about the reflection and the stretch. So for my squared function, I would start off at 1, 1. But I'm going to reflect in this, which is like my new x-axis, and then my stretch is 4, so basically I'm at -1, so I need to go to 4. That's 1, 2, 3, 4. My next point for my reciprocal squared would be 2, 1/4. So I'd reflect that and become right here. Then that -1/4 times 4 is just -1, so I'd be right here. Then I'd be at 1/2 4, reflect that down here, multiply that by 4, I'm way off my graph, so it's not even worth it. And this is what this piece would look like. Then I have symmetry, so I don't have to go through all that counting again. This just reflects over here. This reflects over here. And this is my sketch. Any questions at all? Okay, so then my domain, -infinity to 0, 0 to infinity. My range, though, I'm going from negative infinity to 1. And I don't include either one of them. What questions do we have? Anything at all? Give you a second to finish writing. And then we're going to go to whatever number's right below it. Probably 8, I guess, if I numbered them correctly. All right, so we're going to do number 8 together, and then you're going to do number 9 on your own. Okay, so number 8. My asymptotes are going to be, so this gets shifted which direction? Left or right? Left. So I'm going to go left 4. So since instead of being at 0, I'm at x equals negative 4, which is also just like finding the zeros of the denominator. And then it gets shifted down 7. So then this is y equals negative 7. And then I'm going to get my asymptotes sketched in. So go to negative 4. And negative 7. Okay. So I've taken care of the 7 and the 4 graphically already. So all I have to worry about is the stretch. And then pay attention if you've got a reciprocal or reciprocal squared so you don't do anything weird. So these are my new x and y axis, right? I'm just ignoring the rest. So I would start at 1, 1, but I have a vertical stretch of 2, so it'd actually go to 2. I'd be at 2, 1/2, but I multiply that y value by 2 and it becomes 1. At 1/2, I'd be at 2, multiply that by 2 and I get 4, and I'm right there. So then this is going to look like this. Mine curves out just a little bit there, but okay, so then I'd be at negative 1, but I have to multiply that by 2. So I get that 2 right there. Negative 2, negative 1/2 multiplies to give me negative 1. And then negative 1/2, negative 2, which becomes negative 4, which is off my graph, but it's like right there. I think I can graph that. And that's what my function looks like. So I should be able to get my domain. I'm going from negative infinity to negative 4. Notice how that matches my asymptote over there. And then negative 4 to infinity. My range goes from negative infinity to negative 7. Notice how that matches my asymptote. And then negative 7 to infinity. Any questions at all? Alrighty, then I want you to do number 9 on your own. So if you're done with this one, go ahead and get started on that one. Any questions at all? If you're not done yet, that's okay. When you're finished, double check up here with me, and let me know if you have questions. Your assignment is in Schoology, so you're either going to do it in Cami and turn it in that way, or you can print it out and upload a PDF. I don't care either way. But you're not doing the whole thing, so make sure you read the directions. Off the top of my head, I don't remember. I know it wasn't odds or evens. It was just only do 1 through something, but I don't want to lie to you and tell you the wrong number. But it says it in the directions, so just read it, okay? Any questions at all? Alrighty.